Good afternoon, ladies and gentlemen. It's an honor for me to be invited at this wonderful meeting devoted to the memory of Sergej Zilitinkevich, outstanding international meteorologist. First of all, I would like to say my warm words, my condolences, and convey my very best memories to the widow of Sergej, Irina Bashmakova. We met with Sergej quite recently, but right away he became interested in big data theory and practice. And we were thinking to do many important projects on this matter in future, but unfortunately that hasn't happened. I start with my presentation. Big data in earth sciences and Zilitinkevich's conception. First of all, about Sergej. Professor of numerous universities in the USSR, Russia, Finland, and Sweden. Sergej Zilitinkevich, born in Leningrad, USSR, died in Helsinki, Finland. This is one of the many sides of his personality that makes him really international. His field of research are meteorology, oceanology, environmental physics, astrophysics, theory of turbulence. Winner of 7 European, 2 Finnish, and 2 Russian important research grants. Scientific advisor of 22 PhDs and 3 doctors of sciences in the USSR, Sweden, and Finland. Member of the Academia Europea, Finnish Academy of Sciences and Letters, Eurasian Academy of Sciences. He is also members of numerous outstanding international societies and national societies. He was elected quite recently honorary member of European Geophysical Union. His H index equal to 45 in Web of Science. Our first meeting with Sergej happened on the 15th of January 2020 in Moscow, in my institute, Geophysical Center of Russian Academy of Sciences. My colleagues, including our director, Professor Anatoly Solovyov, joined us, and we really enjoyed discussing many points, and we came little by little, we came to big data, and then the rest of our discussion was about it. Big data discussions continued in Finland in February, a month later, when I visited this wonderful country and was hosted in particular at the observatory Hyutala, and you see academician Kulmala, myself, Sergej Zilitinkevich, and our host at the observatory. 21st century revolution in data sciences, the transition of the information quantity into the quality of the problem solution is the mainstream of big data theory and practice. Nowadays, it is among the most discussed concepts in the data sciences and IT industry. Data is no longer considered as static. It has become a material for creating new economic values. In the 2000s, software concept MapReduce, Google, and software platform Hadoop have appeared. For them, original information no longer needs to be lined up with in-need DBMS. In result, big data processing technologies emerged without rigid hierarchy and homogeneity. MapReduce. This is the key point. This is the start, and if you wish, the most powerful concept in big data exploration. Imagine you have many different pizzas over here that consists of many different ingredients, including yellow, red, and blue, and they are constructed in a different way. Pizza is quite complicated creation, and we, in the end of the corridor, we want to create a sandwich, which is much simpler construction, which will just have dough, bread, then meat, cheese, and maybe vegetables. For that, we should decompose our pizzas, but we decompose it in a special big data way. We create containers, we create repositories of similar quality matters, like red will be meat, yellow will be milk points, milk objects, and blue will be vegetables. So we shuffle those containers, so the repositories, with all we can collect from pizzas. But we don't care about the time order or even any order. If this order exists, we include it, of course, in our repositories. If not, it doesn't matter. We keep it as it is. And this is a big advantage of big data approach, since we don't need to spend or to waste a lot of time in ordering our data. Then we have those containers with initial products, and we come to the procedures of sandwiches creating. But first, we have to merge in one big container all the meat, in another big container all the cheese, and in the third big container the vegetables, let's say. Finally, we come up with this yellow sandwich. In the data theory, big data has formal definition. Here it is. Horizontal scaling is dividing the system into smaller structural components and spacing them into separate physical machines, and/or increasing the number of servers, nodes, and processors that simultaneously perform the same function. Big data is structures and unstructured, what is very important. Data of huge volumes and significant diversity, efficiently processed with high velocity by horizontally scalable software alternative to traditional DBMS. Just huge volume of the data is not what big data means. Big data means three things: big volume, big velocity, big variety. How big? That's not possible to answer this question, since this changes with time. The data which yesterday, let's say 10 years ago, was big, now it's not big data at all. One particular point, variety, can not exist at the moment, but that can be abilities, that can be visible abilities of the system to have such high variety, big variety in future. This we call variability. In some cases, big data that possess variability instead of variety can be considered as future prototype of big data. The best example of big data is internet, of course. Here you see what happened in 2020 every minute on internet. So the object of this data set, of this big data sample, is internet logins all over the world. It would be a mistake to say that all geophysical data make big data. No, there are just some of them that are big at the moment. This is meteorological data, Earth remote sensing data, ecological superstation SMER information seems to be a great example of big data once those stations will be deployed worldwide. Oil and gas seismic surveys, seismograms monitoring, mining sciences. Here are mostly big data examples in the data science. Big data changes our research paradigm, and this may be the most important point. In the big data world, the search for causality is being transferred into the search for the correlations and trends. The data processing, in order to answer the question why, is replaced by the search for the answer to the question what is it in reality. This change in the research paradigm shortens the transition from analysis to prediction. If something happens, we don't need anymore to look into the past and try to construct the model. Instead, we need big data. We need very much data, very fast, and very variable data to put them into sometimes existing algorithm to enhance the study and to find the answer to the question what to do in the present situation. The latter is described by the chess example. Last 50 years, chess computer programs have not become really stronger since the rules of the game stayed unchanged. During this period, last 50 years, the chess program results vastly enhanced, however. The reason is that this 50 years period, the system became able to explore immensely more data. Variance of endgame, n not bigger than 6, n is the number of figures, are completely analyzed by modern chess computer programs. But that was like that 50 years ago also. Programs did not really much change. They stay as they were from Botvinnik's time. Number of the moves in the end game generates a set of more than a terabyte, 10 in a 12 degree byte. Big data technology allows to compress it into a table that can be efficiently analyzed by chess computer algorithms. Thus, computers become practically invincible in the end game. Here are just the list of the methods that people use to exploit knowledge from the big data. We could list many others, many other methods. For the moment, we made just 1, 2, 3% of the whole road to clear understanding what can we do, what great, what useful can we do with the big data in future. We continue to go this road, attracting young people to that study. Always remembering what famous American mathematician Norbert Wiener said: the highest purpose of mathematics is to find order in the chaos which surrounds us. Thank you very much.